Electricity is kind of the lifeblood of our whole world, right? It powers pretty much everything. But here's the crazy thing. It's also super dangerous. It's always trying to find the quickest way to the ground. So the big question is, how in the world do we control all that massive power?
All right, so let's get right into it. The answer? It's all about a group of materials that are just as critical as the wires themselves, but they totally fly under the radar. Yeah, we're talking about electrical insulators.
So what is an insulator really? Well, at its most basic level, it's a material that basically just tells electricity, nope, you're not passing through here. You see, unlike a conductor that lets electrons just zoom on by, an insulator's atoms grab onto their electrons super tightly. They create this wall, this barrier, that electricity has a really hard time getting through.
And this really shows you the two sides of the coin for any electrical system. I mean, you absolutely can't have one without the other. Think of it like this. Conductors, like copper wire, that's the highway for the electricity. But the insulators, well, they're the guardrails. They are what keeps all that power on the road where it's supposed to be and stops it from causing a huge, disastrous crash.
So, when you think of insulators, you're probably picturing those huge things on power lines, right? But the truth is, they're everywhere. I mean, literally all around us, hiding in plain sight. Let's actually break down 5 examples that you almost definitely deal with every single day. Okay, let's do it. We're going to look at 5 key types of these materials, covering everything from the stuff in your house to the heavy-duty industrial ones. All right, number 1, and this is probably the one you see the most, rubber and plastics, like PVC. Just think about any cord or cable in your house. That flexible coating, that's the insulator. Its entire job is to do one thing: keep the electricity safely inside the wire and, away from you. Next up, we've got the real heavyweights, glass and porcelain. Seriously, next time you're outside, just look up at a utility pole. You'll see these disc-shaped things made of ceramic or glass. Their job is to keep the super high-voltage power lines from touching the pole itself. They have to be incredibly tough to stand up to heat, rain, snow, you name it. Perfect for the brutal job of holding up our power grid. Okay, now for the modern stuff that's really changing the game: fiberglass and composites. More and more, these are what's being used in newer systems. Why? Well, they're fantastic insulators, but they have a huge advantage over the old-school porcelain. They're incredibly strong, but also way lighter. Now this one might actually surprise you. Did you know that pure water, I'm talking chemically pure, deionized water, is an insulator? Yep. It's all the minerals and stuff in our regular tap water that lets electricity flow through it. But you know what the most common insulator on the entire planet is? It's just air, the air all around us. That big space you see between overhead power lines, that's not empty space, that's the insulation. And finally, number 5. You know those big gray metal boxes you see on the ground in some neighborhoods? Inside those transformers, they're filled with special industrial oils. And this oil is pretty brilliant, actually, because it does 2 jobs at once. First, it's a fantastic insulator that stops electricity from jumping around where it shouldn't. And second, it acts as a coolant, pulling heat away from the heart of the transformer to keep it from overheating.
So, okay, that's the everyday stuff, but what happens when we go big? I mean, really big, like the massive voltages flowing through the national power grid. Well, that's a whole different level. The engineering challenge is just immense. The insulators have to be tougher, stronger. Basically, everything gets dialed up to 11. For an insulator to even survive out there, it needs to have 3 key things going for it. First is something called high dielectric strength. Just think of it as its ability to not get zapped or punctured by super high voltage. Second, it needs thermal stability. It can't fall apart when things get really hot. And third, it has to have mechanical durability. It's got to be tough enough to handle decades of wind, ice, and constant vibration. And you can really see here how the design gets more and more complex as the voltage goes up. For your local neighborhood lines, these simple pin-type insulators do the job just fine. But for the big transmission lines, carrying way more power, they use suspension insulators. You've seen them, those long strings of ceramic discs. And it's simple, really. The higher the voltage, the more discs you need to add to the string. And then you get to the really high-end stuff. Inside critical gear like circuit breakers, they use a special gas called SF6. It's an incredible insulator, way better than air. The only catch? It's a pretty nasty greenhouse gas, so the industry is working hard to find better alternatives.
So when you put it all together, it's pretty clear, right? These things aren't just passive little bits of ceramic or plastic. No way. They are active guardians. They are constantly working to perform these critical jobs that make our entire electric world even possible.
They really boil down to three main jobs. First, and this is the big one, safety. They stop you from getting shocked and prevent fires. Second, they protect all the really expensive equipment from being destroyed by short circuits. And third, they make the whole grid efficient. They stop power from just leaking away into the ground, so the electricity that gets made actually gets to your house.
You know, one of the sources for this explainer, a senior electrical engineer named Thor, he put it perfectly. He said, electrical insulators are the unsung heroes of our power infrastructure, keeping electricity exactly where it needs to be. And that's just it. They're the silent heroes that let everything else work.
Think about it. Pretty much every single part of our society relies on electricity just being there. And that whole gigantic system completely depends on these overlooked materials doing their job flawlessly, 24/7. So I'll leave you with this question to think about. Our world absolutely runs on electricity. So what happens when its silent guardians fail?